Okay, so here's the example that we have in class. So we want to see whether or not animals on a high-fat or regular diet are going to have increase or decrease in cognition. And then we want to look also at the effects of exercise. So this is a two-way ANOVA or a factorial ANOVA. Specifically, it's a 2x2 because you have two independent variables, one being diet, the other being exercise, and each of them has two levels: diet, regular and high fat; exercise, yes or no. Okay, so we want to compute a two-way between subjects ANOVA using a 0.05 level of significance. So the very first thing that we need to do is we're going to ultimately look at our hypotheses. So we have three different hypotheses, right? So we have our null being there's no difference in factor A. We can also say no difference for factor B, and then no interaction between A and B. Our alternatives is going to be at least one mean in A differs. The second alternative will be at least one mean in B differs. And then for the interaction, we will say that there is an interaction. Okay? So we have our hypotheses for our given experiment. Now our degrees of freedom are going to be defined where the degrees of freedom for factor A equals the number of groups in factor A minus 1. So here we have 2 because we have the number of groups in our first factor, so that's diet, minus 1 is equal to 1. For factor B, exercise, we have the number of groups in B, so 2 minus 1, and that is equal to 1. For the degrees of freedom for A times B, this is going to be equal to the number of groups of A minus 1 times the number of groups of B minus 1. So this is equal to 1 times 1, which equals 1. Now your degrees of freedom for error is equal to the number of groups of A, so that's 2, multiplied by the number of groups of B, that is also 2, multiplied by n minus 1. In this context, n is going to be the number of values in a cell. And so here are your cells. You have 4 cells. Okay, so that is 5, because we have 5 values in each cell, minus 1. So that's 2 times 2 times 4, which is going to give us 16. Okay, now your degrees of freedom total is going to be equal to n minus 1. We have 20 total scores, so this is going to be equal to 20 minus 1, which equals 19. Now note the relationship here. 19 total, we have 1 plus 1 is 2, plus 1 is 3, plus 16 is 19. The degrees of freedom for everything that is making up our total adds up to our total, okay? All right, so now for some calculations. So to get our sum of squares total, this is going to be equal to the sum of x squared minus the sum of the x's squared divided by the total sample size, okay? So what I recommend doing is going up to your individual cells, and you're going to calculate the sum of x's and you're also going to calculate the sum of those x squared values. Now what these values mean are that the sum of x for this cell is going to be 15 plus 20 plus 25 plus 20 plus 10. So that gives you 90. The sum of x squared for this cell is 15 squared plus 20 squared plus 25 squared plus 20 squared plus 10 squared, and that's going to give you 1,750. So you're going to do this for each of these, and I've already gone ahead and added these up separately. Okay, so here we have our sums for each of the cells, and then we have the sum of the x squared values. Now, going down to our sum of squares total, the sum of the x squared values, okay, this is going to be equal to the sum of the x squareds in cell 1 plus cell 2 plus cell 3 plus cell 4. So what I'm going to do is I'm actually going to open up my calculator, and I'm going to put in 1750 plus 4050 plus 2,275 plus 10,525. So this term is equal to 18,600. Now we're going to subtract from that the sum of all the x's. So here we're going to take 90 plus 140 plus 105 plus 225. That gives us 560 squared divided by 20. Okay, so that equals 18,600 minus 560 times 560 divided by 20. That gives us a value of 15,680. So 18,600 minus 15,680 gives us a sum of squares total of 2,920. Okay, that's our sum of squares total. Everything that we get from here on out needs to add up all together to 2,920. Okay, sum of squares for factor A is equal to the sum of x's in factor A squared divided by the number in each of those cells of A minus the sum of x's squared divided by n. And here, note that this is the same as this, okay? So what does this term mean? So this term is going to say that we're going to take the sum of the x's in factor A, okay? So we call factor A, let's say, diet. So we are going to do, in factor A, regular diet, 90 plus 105. 90 plus 105 gives us a value of 195 divided by 10. And where does the 10 come from? In this level of diet, we have 5 numbers here, 5 numbers here. We're collapsing across here because remember, when we're looking at main effects, we are ignoring the effects of the second factor. So 195 squared divided by 10 plus 140 plus 225, which gives us a value of 365. Divided by 10. So this altogether gives us 17,125. Now we subtract 15,680. So your sum of squares for A is going to be equal to 1,445. Okay. Now, sum of squares for B is going to be done the same exact way, except here we're going to be adding across. So your sum of squares b is the same exact formula, except here we have the sum of scores in b squared divided by the number of scores in that level of b minus the sum of x's squared divided by n. So here in b we have 230 squared divided by 10 plus 330 squared divided by 10. Now where did those numbers come from? 90 plus 140 gives us a total here of 230. Remember, we're collapsing across the second variable. Here, 105 plus 225 gives us a value of 330. So these are where these numbers came from. So these are all in one term together, minus 15,680. So this term together comes out to 16,180 minus 15,680, which gives us, pull up my calculator, 16,180 minus 15,680. This gives us a value of 500. So let's separate these a little bit. So SSB. Okay, so now your sum of squares for the interaction is going to be equal to the sum. And what we're going to do is we're going to sum up all the x values in each cell. So there's 4 cells squared divided by the number in each cell minus sum of x's squared divided by n. So what does this look like? Well, this is just this. We have the sum of the x's in the first cell is 90. So 90 squared divided by 5, because there's 5 numbers in that cell. Then we're going to add 140 squared divided by 5 plus 105 squared divided by 5 plus 225 divided by 5. So we're going to add those together. Then we're going to subtract where's this value? 15,680, because that's what this term is. Now what I forgot to also include is that when we're calculating the interaction sums of squares, we're also going to subtract the sum of squares of A, and we're also going to subtract the sum of squares of B. So here we have this term right here, minus 15,680, minus 1,445, because that's the sum of squares of A, and then minus 500, because that was the sum of squares of B. So this is going to give us 17,870 minus 15,680 minus 1,445 minus 500. So the sum of squares for the interaction is going to give us a total of 245. So let me here get a highlighter. So here's our sum of squares total, our sum of squares for the interaction, our sum of squares for B, and then our sum of squares for A. So these are the components that we need. Now remember our degrees of freedom for A, degrees of freedom for B, degrees of freedom for the interaction, and the degrees of freedom for error. So now we have the sum of squares for our various components. We have our degrees of freedom for our various components. Now, all we need to do is just actually make the ANOVA summary table. Now, one last thing that we haven't done is we found the total sum of squares, we found A, we found B, and we found the interaction. But what about the error? Well, the good thing about the error is just that you take the sum of squares total, right? You take the sum of squares total, which was 2,920, and you subtract 1,445 from A. you subtract 500 from B, and then you subtract 245 from the interaction, and this is going to give you your sum of squares for error, which if you do the calculation, so 2920 minus 1445 minus 500 minus 245, you get the error as 730. So what you should do now is if you add up all these individual values, you should get a total of 2,920. Okay. Now, what I'm going to do is I'm going to bring in another piece of paper, and we're going to draw this ANOVA summary table. So here we have our source. So here is A, so we'll call this one diet. B, we'll call this exercise. We have A times B, we have error, and we have total. Okay? Now our sums of squares for A, 1,445. And these are arbitrary, right? You can make diet B if you want to. Just keep track of what you're actually labeling them as. For exercise, we had a value of 500. For the interaction, we had 245. For error, we have 730. And then these all add up together to give us 2,920. Now, moving over, we have degrees of freedom. So degrees of freedom for A was 1, B was 1, A times B was 1, error was 16, and then your total was 19, okay? Now, to solve for mean squared or your variance, you just take your sum of squares divided by degrees of freedom. So 1,445, 500 divided by 1 is 500. 245 divided by 1 is 245, right? Mean squared error, 730 divided by 16. So let me pull up the calculator. 730 divided by 16 is 45.625, okay? Now, for our F value, we're actually gonna have 3 F values. You're going to have an F value for A, an F value for B, and an F value for the interaction. So we have 1445 divided by 45.625, and this will give us a value of 31.67. For factor B, you take 500 divided by 45.625, and you're going to get a value of 10.96. Here, 245 divided by 45.625 is going to give you a value of 5.37. Now, what do you compare these obtained values to? You compare them to critical values. So your critical values are going to be F for 116. This first number is going to be your between groups. So notice in this example, your degrees of freedom for everything is the exact same. And then you're always going to have error be that column value. So one thing, and what we'll do is we'll move over here and we'll look at our summary table. For an F of 0.05, for 1, and then down to 16, 4.49, 4.494. So equals 4.494. Note that each of our F values is greater than that at a 0.05 level, meaning that there's a significant main effect of diet, there's a significant main effect of exercise, and there's a significant interaction. And remember, when there's a significant interaction, we're going to pay a lot more attention to this value because it means that across levels of diet, for instance, exercise is going to influence this or vice versa. And what we'll do is we'll look at actually how that is influenced by this interaction. So that, in a nutshell, is how you come up with these values for a factorial ANOVA. So what I recommend that you do is go through this whole process again. Start with finding the sum of x's and the sum of x squareds. Go through the hypotheses, find your degrees of freedom, and then also go through the sums of squares. So use the formulas that I've provided for you in the PowerPoints, as well as the formulas here. And then create the summary table.